Okay, Stats, so this sheet that I've produced here, if you don't have a printer at home, you could just kind of do a little sketch, because actually the values on this scatter graph don't really matter. So just do yourself a very quick sketch of a scatter graph. Make sure you've got some points that look roughly like that. It's a very weak positive correlation, and you've got your line here. Okay, make sure that your points are spread around this kind of 2/3 of the graph, not here. Okay, so we're going to just use this sheet to talk about some of your key ideas, and the first one is the line of best fit. Okay, so what is this line of best fit? It's a line goes through the mean point and shows the correlation. Okay, so the important thing about a line of best fit, you can't have a perfect one. Don't try to make it go through the origin, that's not correct. Try and get a line that kind of best reflects the way the points are kind of arranged, so it's kind of the best indication you can show. Now, you definitely need to go through the mean point with your line of best fit, and the mean point, it's the sum of your x values divided by the frequency and the sum of your y values divided by the frequency as a coordinate. So what that means is you add up all of your x values and you divide by how many points there are, add up all of your y values, divide by how many points there are, and then you should get a point. I'm just going to stick that on there, it's just an estimate. Now that will give you something to anchor your line of best fit, because it's definitely got to go through that point, and then you can just have a think about what the angle is that best reflects the whole of the data. Okay, two important ideas. Now we can use our line of best fit to make estimates. So if I spend 50 minutes revising each day, what's the estimate of my maths score? It's only an estimate. So I go up at 50 and I go along and I say, I reckon this person might get 66 in their maths test. And I can make all sorts of estimates from this, but some of my estimates are better estimates than other estimates, and this is where these two words come in. Now this estimate here, it's interpolating, it's making an estimate within the range of my data. Very important to understand that this is a safer, better estimate. Okay, so it is more likely to be accurate. Of course, it's still just an estimate, but it's more likely to be accurate. Now, what if I said people who spend 10 minutes revising a day, what do we reckon they're going to get? We reckon they're going to get 44. Well, you're perfectly able to make this estimate, and you might be asked in exam questions actually to make an estimate like that. That's perfectly okay, and you can say, yeah, let's say 44. However, it's not as likely to be accurate. So it's making an estimate outside of the range of the data, and it's less likely to be accurate as trends do not always continue. And I think we talked about in class this idea of trends not always continuing. So if you have a nice hot day, hotter, more and more children at the paddling pool. However, it would get to a point where it was so hot that people would probably keep their small children at home because of sunburn. It would also get to a point where it was so cold that the visitors would just go off to zero. Perhaps they wouldn't open the paddling pool at all. So estimates outside of your range are perfectly valid things to do, but you need to show that you're aware that there's a problem here. It could be if you only spent 10 minutes revising per day, you couldn't get any marks on that maths test because there's too many things to learn. Okay, so you don't know, and this is less accurate. And it's called extrapolating. You don't need to use that specific word in exams, but to be honest, if you do use that word, you've instantly got marks. You can say trends do not always continue. We don't know whether they do or not in this case at all. Okay, so a couple of ideas now for you to have a look at. The first one, I think you're going to be really, really quick on it. It's basically, can you sketch what would look like a strong positive, a weak positive, a strong negative, a weak negative, and no correlation. So just put some blobs of data on there so that you've got a record of it. And the next thing is something that you don't actually need to know in maths class, but in stats class you do need to know. Now, we want to think about when we've got two variables, which one do we think causes the other? We can't always say 100% for sure, and nobody's asking you to. Examples they give you in exam situations are usually pretty obvious. So let's have a look at this one. Temperature and woolly hat sales. So let's play around with the words. Because it's hot, we sell less hats. Because the day has decided to be hot, sales have gone down. Does that make sense? Or does it make sense that because the woolly sales are low, because the woolly hat sales are low, the temperature has decided to be high? That doesn't make any sense, does it? So what that means is that temperature is causing a change to woolly hat sales. Temperature is the thing that explains the hat sales. The hat sales don't cause or explain the temperature. It doesn't work that way around. And the important thing to understand is this is called an explanatory. Okay, so explanatory, and this is causes. Okay, so it's causing the woolly hat sales. Explanatory goes on the x-axis. Okay, so that's the temperature and the hat sales. So what I'd like you to do, please, if you can pause the video, I'd like you to do your sketches and I'd like you to have a go at the other situations. How did you get on? Here's one I prepared earlier. Now, that's a strong positive. Doesn't have to go through the origin at all, but it does have to be pretty lined up. Weak positive, a bit more spread out, but definitely there's a pattern going up. Strong negative, weak negative, more spread out, and it looks like a snowstorm. There is no correlation. There doesn't seem to be any link between the variables. Okay, so rising temperature causes reducing hat sales. So that means the temperature is causing the hat sales to change. The temperature goes on the x-axis. Right, so time spent revising causes you to have a higher mark, or is it that the higher mark that you get causes you to have spent more time revising? Well, time doesn't run backwards, so that doesn't make any sense. The more time you spend revising will affect your mark. So revising goes on the x-axis. How far you live from school and how long it takes to get to school. Well, the thing that causes the length of the journey is how long the distance is. So it's causing you to take longer to get to school. So it is the explanatory variable. It goes on the x-axis. And then here, age and height. Is it the case that your age, how long you've been growing, is causing your height to keep growing, increasing? Or is your height being really high, meaning that you are then therefore older? Does it make you older? No, it doesn't. Age is the explanatory variable. Okay, thank you very much for listening.